Welcome to episode 7 of 5 Minutes with an RCDD podcast. In celebration of National Fire Prevention Week, we're talking about fire stopping. So come with us as we talk about this interesting subject.
Don't hang up that phone. We've found what you're looking for. Welcome to the 5 Minutes with RCDD podcast. Well, seeing how we're pulling Category 6A, the most powerful twisted pier in the world, you gotta ask yourself this one question. Did I pull 295 or 300 feet? Well, do you feel lucky? Do you, punk? In this podcast, you'll learn the differences between a 66 and 110 punch tool, the proper way to install a support cable, along with terminating and testing parameters. What exactly does RCDD stand for? Really can't do diddly? Or just some guy that's just sitting around in a chair making podcasts. So join us as we talk about the ever-changing world of telecommunications, from ISP to OSP, from copper to fiber, design to installation. Now send the new guy to the truck for a bucket of dial tone and the cable stretchers, while you listen to an informative program on telecommunications. Here's your host, Chuck Bowser, RCDD.
So welcome. As I mentioned, we just finished National Fire Prevention Week. It's held every year from October 4th to October 10th. National Fire Prevention Week has been around since the early 20s. And in honor of that, we're going to discuss fire stopping today. Now, you probably wonder what makes me qualified to talk about fire stopping. Well, you already know my ICT history. I'm an RCDD, a Bixie technician, a former Bixie trainer. So you already know all that if you've been listening to the podcast. I've also attended and passed the Hilti Train the Trainer program to teach fire stopping, and I spent 5 years as a volunteer firefighter. I went through classes and got certified as a firefighter and an EMT. So I think because of all that stuff, I can discuss this subject matter and really talk to you guys about it and maybe hopefully enlighten you. So getting back to first off, let's talk about what is the NFPA. The NFPA is the National Fire Prevention Association. They were created in 1896, which is kind of ironic because the first electrical code book was published in 1897, which the NFPA produces. It's kind of funny how that happens, right? They are devoted to basically eliminating death and injury from property and economic loss from fire, electrical, and also other related hazards. So they published, like as I mentioned, the NFPA 70. You probably know that as the National Electrical Code Book. They are considered experts in fire. So the NFPA basically has this thing called the National Fire Prevention Week. It's to commemorate the Chicago fire that basically took 250 people's lives, left 100,000 people homeless, and destroyed over 17,000 building structures. And it started October 8th in like 1871 and it burned for several days. So because of that, they decided to go ahead and have a National Fire Prevention Week, basically to do two things. Number one, to teach children and adults how to stay safe in the event of fire. That's where you got that whole stop, drop, and roll thing from. And every year they pick out a new topic. And also the other part of that is it's also for firefighters to provide life-saving public education opportunities. When I used to be a volunteer firefighter, we used to have open house, and it was always on October 10th, whatever the last Saturday is of that week. And so I've been aware of National Fire Prevention Week for years. Matter of fact, we used to have the open house there at our fire department, Engine Company 11, Prince George's County. It was always on a Saturday. So the theme for this year is actually cooking safety, because a lot of fires actually start from kitchens, people leaving their burners on or causing problems. Matter of fact, I'm guilty of that. I've done that more than once, unfortunately. Not caused a fire, but left the burner on, and then next thing you know, the smoke alarm is going off, and then the security company's calling you up. Mr. Mauser, are you safe? Yes, we're safe. I was just cooking again. Yeah. Now, since this show focuses on commercial buildings, we're going to talk about industrial plants, commercial office buildings, hospitals, stuff like that. The NFPA published a report a few years ago. It covered from the years 2014 to the year 2018. During that 4-year time span, they found that there were 493,000 fires. There was over 2,800 civilian deaths and over 12,000 injuries. On top of that, there's $10.5 billion worth of damage done. Now, you probably wonder, well, how does this apply to you? How does this apply to me, the ICT installer? Well, number one, get training, right? Hilti, STI, Unique Firestop Systems, or just ones I can think of off the top of my head that provide free training sessions for you. Some of them are face-to-face, some of them are online. Depends on what your best learning skill is to take that. But again, get the training. And then once you get that training, apply that training. Okay, it's knowledge plus experience equals what? If you watch my LinkedIn post, you saw that. That's your homework assignment. See what that is and put it in the thing. You can't just, having knowledge by itself doesn't give you the wisdom. So you got to apply everything that you learn in those classes. And then the third thing you need to do is teach somebody these new skill sets that you just learned. Right? We as an ICT industry, we're great at keeping information close to our vest. We don't like teaching people for some reason. I don't understand why. We need to get better at that. This is part of what this whole intent is for. This podcast is for, is to help do that. So once you knew this information and you learned it and you're applying it out in the field and you're getting the wisdom from that, then go ahead and teach somebody, because that's going to do two things. One, it's going to make them better, make more people safer, because they're not always going to be working with you, and it reinforces that knowledge within you. Right? It helps solidify that knowledge in you so you can recall it easier. So what does the code book say about fire stopping? Now, since there are some legal ramifications about, what the code book says, and again, the authority having jurisdiction, the electrical inspector, they always have the final say in the matter. So before you try to do anything, always make sure that you verify with them how they interpret the code book, because that's what really matters. Not what I say, not what you say, not what Joe Blow says out on the street. It's what your AHJ says that really matters. How they interpret the code book. Now, since there's some legal ramifications, and I am not a lawyer, and I didn't stay at Holiday Inn Select last night, so I can't even pretend to be a lawyer. Right? In some areas, it is actually a felony to interpret law. So I'm going to read these few things right straight from the code book, so that way you understand what they are. So the first thing we need to do is we need to build a foundation. And the foundation is we have to know what certain terms mean, because they definitely mean certain things. And you have to understand those meanings in order to be able to understand what the code book is trying to tell you. Because trust me, the code book doesn't talk to you in layman's terms. Those terms are going to be listed, labeled, approved, should, and shall. So let's first talk about that first word, listed. Now, in order to find what these definitions are, you got to go to chapter 1 in the code book. All right, that's where you'll find all of the definitions. So I'm going to open up my code book so you can actually see this. I'm going to put on my approved safety glasses. These are not reading glasses, people. These are safety glasses. I'm wearing my appropriate PPE. So let's see. Okay, what does the term listed mean? Listed means, again, verbatim from the code book, equipment, material, or services included in a list published by an organization that is acceptable to the authority having jurisdiction and concerned with the evaluation of products or services that maintains periodic inspections of production of listed equipment or materials for periodic evaluation. So basically, if it's listed, that means it's on a list that's approved by the authority having jurisdiction to be installed in their area. They're maintaining a list, and the stuff's on the list can be installed in their area. The second one I want to talk about is approved. Now, listed and approved kind of are similar. So approved is also found in that same section, Article 100. So let me just flip over to approved. And the definition for approved is real simple in the code book. It basically says acceptable to the authority having jurisdiction. So if it's listed, it is therefore approved. Something can be listed and not labeled. Something can be labeled but will never be listed. Not listed. Because in order for it to be labeled, it has to be listed. If that made sense, right? So once something is listed, it's been tested by a third-party company, a nationally recognized testing laboratory, NRTL. Underwriters Laboratories is an example of one of those. Once they test it, they put a label on it. They give the manufacturer the rights to put the UL label on that product. It is now listed and labeled. That's why a lot of electrical inspectors, when they're inspecting products, when they're looking at that jack in the ceiling for that wireless access point, they want to say, is that plenum rated? Well, yes, it is. Well, let me see the UL label. That's what they're doing. They're making sure that it is, in fact, labeled, right? Listed and labeled, similar, but not really exactly the same thing. So now the other two words I want to talk about are should and shall. Boiled down in its most basic elements, shall is a requirement, should is a recommendation. But the code book gets a little bit more specific than that. They're called mandatory and permissive rules. So again, I'm going to flip over to the code book and we're going to read what that is. Mandatory rules, again, straight from the code book. Mandatory rules. Mandatory rules of this code are those that identify actions that are specifically required or prohibited and are characteristic by the use of the terms shall or shall not. So if it says shall, that means you have to do it. If it says shall not, it means you absolutely cannot do it. Right? That's what mandatory rules is. That's where the word shall comes from. And then the word should is a permissive rule, and permissive rules of this code book are those that identify actions that are allowed but not required, are normally used to describe options or alternative methods, and are characterized by the terms shall be permitted or shall not be required. So if you see, shall not be required. So if you see that shall not be required or shall be permitted, it is a recommendation, meaning you can do consideration that week. So now that we got that foundation, we understand those 5 really critical words. Now let's go to Article 800.26 and see what the code book says about fire stopping. So let's just flip our code books. If you're following along, it's 800.26. If you are in the 2020 code book, that is page, 70- something or another. 70-664, but actually 665. So what does it say about fire stopping? 800.26, it's titled Spread of Fire or Products of Combustion. Here's what it says. Installation of cables, communication raceways, cable routing assemblies installed in hollow spaces, vertical shafts, or ventilations of air handling ducts shall, again, that's why we went over that word shall just a moment ago, shall be made so that the possible spread of fire or products of combustion will not be substantially increased. These openings around those penetrations of cables, communication raceways, and cable routing assemblies through fire resistance rated walls, partitions, floors, or ceilings shall be fire stopped using approved methods to maintain the fire resistance rating. So there, we use the word approved and the word shall in that sense. So basically it's telling you have to put fire stop systems in whatever hole that you made run your cables through. And it's got to be third-party tested. It's got to have a UL label, right? It has to be done. So you're probably wondering, okay, Chuck, what does this mean? Well, let's take a step back. Let's talk about that qualification testing. The NRTL. So there are several companies out there that do NRTL stuff. Underwriters Laboratories is one of them. That's probably the most common one. So when a manufacturer comes up with a new fire stop system and they want to have it listed, they send it to UL. UL puts it in a burn box. They burn it for whatever period of time that they're trying to get that rating for. So let's say, for example, it's 2 hours. They'll burn it for 2 hours, and then if it passes the test, if it passes the F test, the T test, and the L test, it is given a UL document number. It's added to the list of approved products. There's that word list that I was just telling you about, listed. That's why we had to go over this. By the way, that test is not cheap. That test is about $10,000. Because of that, that's why you never mix and match fire stop materials. Because if you start mixing another manufacturer's products with the one that you've got, it's not a tested system. It's not on a list of approved products. That's why it's a code violation. Also, make sure you install that fire stop system per the steps identified in the UL drawing. Okay, I'll talk about what happens if you don't. And here's another critical one. Don't add more material to try to get just a higher rating. It doesn't always work that way. Sometimes, more often than not, it will not give you a higher fire rating, especially when it comes to Firestop materials. So when they do their qualification testing, there's more than three tests. There's all of the tests were based on these three. These are the three foundational tests. You have the F rating test, the T rating test, and the L rating test. So the F rating test is a test that's expressed in hours. And that test basically just they test it to see how long that substance, whatever that Firestop material is, can be burned until finally that material is consumed to the point that permits flame to pass through that opening. That's why it's called the flame test. Because as fire consumes the products of combustion, those materials get smaller. Right? The T test is a temperature test. And what they're doing is, again, it's always expressed in hours, and what they're doing is they're checking the non-fire side of a wall to see how long it takes to get that non-fire side up to 325 degrees above ambient temperature. Now, say, for example, you got your firewall. The fire breaks out on one side of the wall, right? Well, if the ambient temperature is 70 degrees, then that test is going to say it's good to 395 degrees because 325 plus the ambient temperature of 70 degrees is 395. That's where that number comes from. And then the leakage test is, again, it's measurement of how much smoke or toxic off gases that Firestop permits to go through that system at 400 degrees Fahrenheit and also at ambient temperature. So they take two different messages because the number one killer of people in a building fire is smoke inhalation, right? So what happens when you are compliant with the code book? Well, first off, number one, you're going to slow or stop the spread of fire in that building, right? Now, fire actually spreads through three different methods: convection, conduction, and radiation. And the Firestop system stops one or more than one of those types of ways of fire from spreading. It keeps it contained. Our job is to contain that fire to as small area as possible so people have time to egress or get out of that building. So conduction, what is conduction? That basically means the transfer of heat within the material itself. Now, an easy example of conduction would be a pot on a stove. If you put a pot on the stove and then you overheat it, well, eventually the handle gets hot. Well, that's because of conduction. Now, how does that really apply to us in the ICT world? That applies to us because think of like a sleeve going through a wall, a Firestop sleeve, or a conduit. So when that fire gets exposed to the conduit on one side, it will heat that conduit up, and that heat will go through the conduit and heat up on the other side of the wall, the non-fire side. Then the second one I talk about is convection. Now, convection is basically the transfer of heat through the movement of hot air. Ovens work that way, convection ovens, right? They heat up the air, that cooks your food. Now, for us, the reason that's important to us is because if you raise the temperature to the point of what's called the auto ignition point of that material, it will spontaneously catch on fire without an ignition source. So, for example, everything has an auto ignition point. So if you go on the internet and you type in auto ignition temperature for paper, you will find that there's a temperature at which if you put the paper in a room and you raise the temperature of that room to that temperature, that paper will spontaneously catch on fire without a spark. That's why you've got to stop that convection from happening, because if paper can do that, so can a cable jacket, so can the dielectric. It can spontaneously catch on fire. And then the third one is radiation. Now, radiation is the energy that gets transferred basically through space to something nearby. An example is when I was in a fire department. I worked for Engine Company 11, Prince George's County Fire Department, affectionately called the Zoo. So College Park, Maryland is a small little community. The houses are pretty close together. The houses are maybe 50, 60 feet apart. They're not that far apart. So if a house would catch on fire, as a member of the engine team, when we got there, you had two different attack teams. You had the exterior attack team and the interior attack team. The interior attack team went in and breached the building and put out the fire. The exterior attack team, what their sole job was, now you're thinking to squirt water on the house that's on fire. No, we would squirt water on the house right next to it, on the wall that faced it. So that way the radiated heat coming off of the house that's burning on fire does not cause the the material on the house right next to catch on fire, right? Well, again, moving to the ICT world, if something catches on fire in the ceiling and it's near a bundle of cables, those bundle of cables can spontaneously catch on fire when they reach that auto ignition point. I was on a cable installation and maintenance webinar once a year or two ago, and there was a cable tray manufacturer on there, and he said basically that if you have a cable tray that's 12 inches wide, filled 6 inches deep, a 6-foot section, when it's on fire, it will put off the same BTUs as a gallon of gasoline. Think about that. That's dangerous, right? A BTU is a British thermal unit. That's how they measure the heat of a fire. So correct fire stopping is going to basically allow people additional time to get out of the building. It's all about escaping. So you want to minimize the risk to legal problems by making sure that you install a listed system, right? So what are those legal legal things you got to worry about? Well, number one, you can be criminally prosecuted for anybody who dies or gets injured in that fire if you don't install that fire stop correctly. You can be held civilly liable for not installing a fire stop correctly. And you're also going to be held financially responsible. Now, not the company. I am talking about you individually. You right there listening or watching this audio or video podcast right now. You can be held liable for this. This is why you want to get training on this. This is why you want to get certified on this, to minimize those risks. So let's talk about a fire stop system. What is a fire stop system? There are 4 elements to a fire stop system. You have the barrier, the thickness of that barrier, whatever it is that's penetrating it, and the fire stop material itself. So those 4 things that make up a fire stop system. Let's talk about those. First one we're going to talk about is the barrier. The barrier is going to be, and it's pretty simple, the floor, the wall, the roof, the ceiling, whatever that barrier is that you're going through that you have to make a hole in. The second thing is, what is the thickness of that barrier? So, for example, a single sheet of 5/8 inch thick plywood, gypsum board is rated for 1/2 hour. So if you got a stud and you got a 5/8 drywall on each side of that stud, that is effectively a 1 hour rated wall. If it has 2 sheets of drywall on each side of that stud, it's effectively a 2 hour rated wall. Now, let's say you don't have a cinder block wall. Don't have a drywall wall. Let's say you have a cinder block wall. Well, a cinder block wall is generally considered a 2 hour rated wall. If you put concrete inside that cinder block, it's a 3 hour rated wall. If you put rebar inside that cinder block with concrete, it's generally considered a 4 hour rated wall. Now, then the next thing you got to worry is what is actually penetrating this barrier? What's penetrating this wall? Is it UTP cable? Is it screened cable? Is it fiber? Is it interduct? Is it a sleeve? Is it a tray? Those are all things that you got to take part of the evaluation process to determine the correct system that you're trying to install. And then the 4th thing is the material used to install that fire stop system. Right? And we're going to go through those different types of properties of those materials here in just a minute. So when it comes to fire stop systems, they are generally available in 2 types of systems, mechanical and non-mechanical. Now, mechanical, as an ICT person, I have never seen a mechanical system installed out in the field. I've seen one once when I used to be the Bixie trainer for Hinkles McCoy. I had got one of the Firestop manufacturers to donate a mechanical system to our Bixie lab so we can show this. So I saw one. It's basically a metal frame, and it's got these little pieces that you put inside, and you peel off the layers to get the right size cable. You put your cable in the hole, you put the top piece. It's made out of elastomeric material. And then there's a bolt on the top. You tighten it down and it compresses it in so it stays all nice and tight. You don't see them too often. You see them a lot on ships. You don't see them too often in the communications world. The more common one that you're going to see is the non-mechanical systems. The non-mechanical systems is going to be putty, caulk, wraps, pillows, cementitious material, all that fun stuff. They all have certain properties to them that are kind of critical. They're going to either be intumescent, endothermic, or ablative, or some combination of those 3. So what it means is if it's intumescent, it means that material, when it gets exposed to fire, it expands, helps swell. It swells when it gets exposed to heat. Why is that important? As a bundle cable gets exposed to fire, and the fire consumes the products of combustion, the cable jacket, the dielectric, any non-conductive filler elements that might be inside, that bundle is going to get smaller and smaller and smaller. Well, if the fire stop material doesn't expand, that creates openings. What goes through those openings? smoke, heat, toxic off gases, things that kill people, right? It also might be endothermic. Endothermic means it absorbs the heat. It helps stop radiation and conduction effects. That's why I went through those terms earlier. So it absorbs that heat so that it doesn't go through to the other side and ignite what's on the other side. And then the last one is going to be ablative. Ablative means it develops a hard char when it gets exposed to heat that seals off that hole or that Firestop sleeve, so smoke and heat and flame and toxic off gases all can't go through that Firestop system. And they're resistant to the fire department when they're putting out the fire. By the way, there's a really great link that you can find on the internet for Firestop glossaries, and I'll put the link of that in the show notes. So let's talk about some tech tips. Number one, never use ordinary grout, plaster, or cement to replace cementitious materials. Cementitious materials is manufactured specifically to stop the spread of smoke, flame, and heat. Those other materials aren't. Also, drywall putty is not a Firestop material. I've been on a lot of job sites where I've seen drywall contractors throw some drywall putty in the hole that some cable contractor made. That's not a Firestop system. And then also, make sure you always follow the UL drawing. Okay? If you don't follow that UL drawing step by step, matter of fact, it's going to tell you how deep that putty has to be. It's going to tell you whether or not you have to have mineral wool inside of that. If it tells you have to have mineral wool and you don't have any, do not go get, fiberglass insulation from the job site and stuff in there. That's not the same stuff. Okay, it's got to be mineral wool. You're also going to find, especially on your round openings, these things called minimum and maximum annular distances. Now, an annular distance is basically how much space is there between the bundle of the cables and the wall of the assembly it's in. So in the UL drawings and your round systems, it's going to specify minimum and maximum numbers. Make sure that you are within those numbers, because if you don't have a listed system. We're already nearly at 25 minutes on this podcast. And I have not even touched the surface on Firestopping. I have not talked about how to select a Firestop system, the process that you go through. I didn't even go through that UL document number, those letters and numbers. What do they actually mean? And so there's a lot of stuff that you can go into depth here. So what I'm going to do is I'm going to create a 2-hour video course that you can take and get your certificate of attendance and earn continuing education credits if you're one of those Bixby certified people like I am. Right? I still recommend that you go to your manufacturers and go get your training on how to install this specific processes, because the steps to actually install it will be different by manufacturer, but the class will give you good overall on how to select and determine the right kind of Firestop systems. So that concludes today's podcast and today's video cast, whatever you want to call it, because it's the first time that I'm attempting to do both the video and audio at the same time. I hope you watch it on YouTube and or LinkedIn, wherever you see this from. Hey, look me up on LinkedIn, shoot me a friend request. And until next time, guys, be safe out there and keep cabling on. Take care.
That's it for this episode of today's podcast. We hope you were able to learn something. Make sure to subscribe so you don't miss out on future content. Also, leave a rating so we can help even more people learn about telecommunications. Until next time, be safe.